Let's do a video on projectile motion, and we're going to go ahead and do a couple of problems. I'm probably going to go through this quicker than your teacher would in class, but you can always stop the video and work it on your own if you wish. But I also want to be efficient in making these videos. What we have here for every problem below, we wish to obtain the projectile's range, which is the maximum horizontal displacement. We also need to find all the other quantities that are listed, not necessarily in any particular order. We're asked to show a calculation for time, and we are assuming that air resistance is negligible and that the value of G is 9.8 meters per second squared. Let's see what we can do here. We're launching something at this initial velocity. The first thing we always do is we find the X and Y components initially of the velocity, Vxi and Vy initial. Or if you want to put a naught symbol there, you can do that. You want to use sine and cosine as appropriate, making sure that your calculator is in degree mode. And when I calculated this for the initial X velocity, I got 50.97 meters per second, and that is to the right. And Vy, I got 35.56 meters per second, and that is upward. Now, I've decided, haven't I, just by using these symbols here, that to the right is positive and up is positive. So the positive x-axis points to the right, the positive y-axis points upward, which means when we specify our acceleration in the y direction, which is due to gravity, that points downward. So that's going to be negative 9.8 meters per second squared here on Earth. And because there's no air resistance, the acceleration in the x direction is 0 meters per second squared. Assuming that this projectile lands at the same elevation as what it was launched at, in other words, it's not launched from the top of a cliff and it doesn't land on a cliff, what that means is that the downward y velocity at the end will be the same in magnitude as the initial upward velocity. So what we can write here, and I'll just go ahead and scratch it down here in the lower left, Vy final is going to equal negative 35.56 meters per second. And that's because it's going downward now. Again, that's only true because we're assuming that the projectile lands at the same elevation as what it was launched at, which means we can calculate the time then. How do we do that? Well, one equation for acceleration is the acceleration, let's say in the y direction, is equal to the change in velocity in the y direction divided by time, which means that time is Vy final, negative 35.56, minus Vy initial, 35.56, divided by negative 9.8, which means when we calculate that out, we figure that the time in the air, I'll go ahead and put that up here, the time in the air comes out to be 7.257 seconds. I'm keeping a few extra significant figures in there because we don't want to round too soon. It will take half this time to get to the top. How far will it go? It will go 50.79 meters per second to the right, that is, for each of 7.257 seconds. And that gives me a number of about 370 meters. Delta y, oh, well, delta y total for the whole trip, delta y is 0. It lands at the same elevation that it was launched from, just about 370 meters downrange.